Okay, in our last video we took a look at how the law of cosines is put together, how it works, where it comes from. And now why don't we just consider an example? So we're going to take a look at applying our knowledge. Alright, so we know that we can write the law of cosines three different ways, depending on which angle we have given. So the first one, if I'm given angle A, then I'm going to start out with a squared equals all of this stuff. If I know what angle B is, or maybe I want to find angle B, then I'm going to start out with b squared equals all this stuff. And then, last of all, if I know angle C, or I want to know angle C, I'm going to start out with c squared equals all of that stuff. So, here's the example that I have for you. In this particular example, I'm going to say that we know three side lengths. So it's a side, side, side type of situation. We have triangle ABC, creatively named, and side A equals 9 units, side B equals 5 units, and side C equals 8 units. First thing we're going to look for is angle A. So here's angle A, found it, done. Nope, just joking. We actually have to solve and figure out the measure of angle A. So, we set up our equation, starting out with a squared equals all that stuff. Next, we plug in our values. We're going to start out with 9 squared equals 5 squared plus 8 squared minus 2 times 5 times 8 times the cosine of angle A. We don't know what angle A is, so we just leave an A in there. Alright, and eventually we're going to solve for A. We have to simplify everything that we have first. So go ahead and square that 5, square your 8, we get 25 plus 64. We can add those because they're separate from the product over here. So we get 89 for their sum. When you multiply 2 times 5 times 8, we get 80. So on the right side of the equation, we have 89 minus 80 times the cosine of A. Okay, time to isolate cosine of A. First, we're going to subtract 89 from both sides of the equation. Make sure that if you do it on one side, you got to do it on the other. Keep it balanced. Equations must be balanced. But when we subtract it, we come up with a negative 8. That's alright though. We have negative 8 equals negative 80 times cosine of A. Alright, how do we get rid of the negative 80? Well, opposite of times negative 80, we have to divide. Divide both sides by negative 80, and we can just leave that as a fraction and simplify it. Here it's simplified down to positive 1/10 because a negative over a negative is a positive. And 8 goes into 8 one time, while 8 goes into 80 10 times here. So it simplifies pretty nicely. So we have 1/10, or 1 over 10, equals cosine of A. Cosine, fraction, ratio. It's all coming back to me. That looks like adjacent over hypotenuse type of situation. Just a little reminder, right? Sounds kind of familiar. So we know that if we have a ratio equaling a cosine of an angle, we can solve for that unknown angle. We just have to use the inverse trig, right? So let's do the inverse of cosine of 1/10 to solve for A. Alright, so let's put that on the calculator. So inverse, we should do the second key for that one. So we have inverse of cosine of 1 over 10. Plug that in. What do we get? Aha, about 84 degrees. Good, so now we know angle A. Well, we can do the same kind of thing to find angle B. So if we're looking for angle B, then we got to start out with b squared equals all that stuff. Plug in the values that we know. Leave a b in there for that unknown angle. Simplify our equation again. So take a minute and look at those operations. Square the 9, square the 8, combine, multiply these here. 2 times 9 times 8. Do not subtract the 144 from the 145. Don't do it. But yes, subtract 145 from both sides of the equation to keep it balanced. We get negative 120 equals negative 144 times cosine of b. And then we almost have b by itself. We're getting there. we need to divide both sides by negative 144, and then just leave it like a fraction again. So much easier. And I simplified it, not all the way, but it won't matter because just like 1/2 equals 2/4, I mean, it's all the same. So you could even leave it as negative 120 over negative 144 if you want to, but I try to make it look a little bit more pretty, so I put 10 over 12. I just divided the numerator and the denominator both by negative 12. But, you know, whatever makes you happy. And then we go with the inverse cosine of 10/12, and that will give us angle B. When I plug that in the calculator, we've got the inverse cosine of 10 over 12 is approximately 34 degrees, or 33 and 6/10 if you want to round it off to the nearest tenths place. Alright, now we could go through all of that again. We could do, you know, to find angle C, we could do C squared equals A squared plus B squared minus 2 blah 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 blah. But we don't even have to do that because we found angle A and we found angle B, and we know that all three angles have to add up to 180 degrees. So here we can just take 180, subtract the angles that we found, and there we are with our remaining angle, about 62 degrees. So we were given three sides of our triangle, and we found all three angles. That's what the law of cosines can do for us. It's pretty awesome stuff. But here's something for you to kind of think about and puzzle over. Why can't we use angle, angle, angle in order to determine a triangle's side lengths? So if we're given a triangle and all three angles are labeled, why can't we find out the side lengths? That's something for you to think about. Okay, until later. See ya.